Environmental pollution due to community activities in disposing of household waste is a major concern in modern life. According to a 2020 report from the Indonesian Environmental Statistics Agency, household waste dominates pollution in Indonesia's water environment, accounting for 86.37% of pollution.
In the household waste category, detergent and inorganic waste are the main contributors. According to research conducted by ERIC in 2019, global detergent production has reached an alarming 2.7 million tons per year, with an annual production increase of 5%.
Household effluents, particularly detergents, can pollute water and disrupt the ecosystem balance. This pollution harms aquatic flora and fauna and affects people who rely on aquatic resources for their daily needs. Therefore, we need some treatments to overcome this issue with synthesis of activated carbon from PET plastic waste as an adsorbent to reduce phosphate levels in detergent waste.
My name is Sulthan Arazaf.
And my name is Nabilul Kamal.
We are from SMA Negeri Modal Bangsa.
The consumption of PET has resulted in an increase in the amount of plastic waste worldwide. This is because PET plastic is economically valuable and designed for single use only, and has a large surface area resulting in activated carbon with a narrow and homogeneous micropore size distribution.
Therefore, PET is more stable to be used as absorbent than other types of plastic.
From this research, we can utilize PET plastic waste to become activated carbon so that we can reduce plastic waste in our environment.
So, how to reduce plastic waste in our life environment?
Of course, we change it into an activated carbon.
Here are the tools and materials that we use in this research. First, clean the PET plastic waste, dry it, and cut it into half centimeter to 2 centimeter size. Second, put the PET plastics into porcelain cup and carbonize at 480 Celsius for 2 hours using a furnace. Third, sieve the carbonized carbon with 150 mesh sieve and soak with acetone for 24 hours. Next, filter and oven dry at 110 Celsius for 3 hours. After that, physical activation at 750 Celsius for 2 hours. Next, chemical activation using KOH4M for 2 hours. Next, filter with wet band paper, wash with distilled water until the pH is neutral. After that, oven dry at 110 Celsius for 3 hours. And finally, activated carbon was characterized using semi-EDS.
Next is testing of phosphate content in detergent waste. Initial with preparation of standard solution and calibration curve. Next, determination of phosphate content in detergent waste. Optimize the spectrophotometer with the phosphate calibration curve. Vary the concentration of phosphate solution with 2, 4, 6, 8, and 10 ppm. Add 1 drop of phenolphthalein indicator, then add 5 N of H2SO4 for neutralization. Add the mixed solution, homogenize, and measure the absorbance with a UV vis spectrophotometer at a wavelength of 880 nanometer. The next step is reduction of phosphate in detergent waste. Put 10 ml of detergent waste sample into a beaker glass and add 0.5 grams of activated carbon. Then stir using a magnetic stirrer in 400 rpm for a varied contact time. The varied contact time is 0, 5, 10, 15, and 20 minutes. Filter the treatment results and analyze the filtrate according to the phosphate determination method. At the initial stage, the process of synthesizing activated carbon from PET plastic waste begins with calcination using a furnace at 480 degrees Celsius for 2 hours. This process aims to enlarge the pores of activated carbon by breaking chemical bonds or oxidizing molecules on the surface.
The next process involves soaking the carbon in acetone for 24 hours to separate element other than carbon during the carbonization process. Afterwards, the carbon was dried for 2 hours to remove the remaining acetone.
The synthesis stage continues with physical activation at 750 degrees Celsius for 2 hours, aiming to open the pores in the activated carbon for a larger surface area.
Next, the carbon was chemically activated by immersing it in a 4M KOH solution. where the concentration of QoS affect the quality of the activated carbon produced.
To obtain neutral activated carbon, it was rinsed with distilled water until reached pH 7. This synthesis was followed by characterization using SEM EDS to look at the surface morphology of activated carbon from PET plastic waste. Figure 4.2 shows the difference in morphology before and after activation, with pores appearing more homogeneous and 20 micrometer in size after activation. The results of the EDS test showed a change in the composition of the activated carbon, with a decrease in the percentage of carbon after physics and chemical activation.
Followed by determination of phosphate level in detergent waste. The result show phosphate level that exceeds the established threshold. The determination of phosphate level with activated carbon involves variation in contact time, with results showing an increase in phosphate absorption up to a contact time for 15 minutes, but decrease at 20 minutes. The optimum contact time for phosphate absorption occurred at time 15 minutes, with an absorption capacity of 0.0062 mg per gram and an absorption percentage of 41.59%. Based on the research that we conducted, PET plastic waste successfully converted into activated carbon, which can be proven by the characterization results using SEM EDS.
In addition, activated carbon from PET also can reduce the phosphate levels by absorbing the phosphate to 41.59% in 50 minutes, with an absorption capacity by 0.0062 mg per gram. That's all the result of our research presentation. Please apologize if there are mistakes in words.
Thanks for attention.
Please support us in ISPO 2024.